fine. So very big question, right? Okay, figure, without looking at the figure we will draw it. Okay, first of all, what figure is given even though in the question, let us analyze it. A metallic rod 1 meter length, right? This 1 meter length is rotated with a frequency 50 hertz, means 50 cycle per second, isn't it? 50 cycle per second means 50 hertz. So it is rotating like this, with one end hinged at the center and the other end, one end is hinged at the center and the other end is at the circumference of a circular metal. So there is the circular metal. So at the center this is hinged and this is hinged at the circumference. Okay, so this is guided, this end is guided by the circumference, isn't it? And this end is pivoted at the center, right? About an axis passes through the center. Okay, about an axis and perpendicular to the plane of this ring. So plane of the ring, let us draw the plane of the ring. First, this is your plane of the ring. Okay, this is the plane of the ring. Okay, next is what you have the center for this. You have the center here, isn't it? At this center, one end is and ring. Okay, consisting. This is also 1 meter, isn't it? So this rod is, I am taking at certain angle, right? And other end is hinged at the circumference. So it is rotating like this, in this manner. It may be clockwise or anti-clockwise, it is not given. Okay, forget about that. So suppose I am taking this anti-clockwise direction. Okay, like this is, it is rotating. Now here you have the axis. About this axis only it is rotating, isn't it, at the center. So this is R is equal to 1 meter. R is equal to length of the ring is equal to length of the rod is equal to 1 meter. Am I correct? R is equal to L is equal to 1 meter. Right? Fine. So this much we came to know. And then a constant and uniform B is parallel to the axis is present everywhere. Uniform B is present everywhere. Okay. So what is the center? Now the B direction they have not given. They have told it is perpendicular to the plane, isn't it? Parallel to the axis. Parallel to the axis means perpendicular to this plane. Am I correct? Parallel to the axis means perpendicular. So I will take the field like this. Means going in. Everywhere it is there. Okay. So everywhere it is there. So I am drawing this. Is it tallying with the given figure?
Yes.
Check. Yeah. Wow, how they have taken the field? Field direction is inside or?
Inside.
Inside only. Okay. Fine. So this is your arrangement, isn't it? Now what is he asking? Find the E. Find the induced EMF, isn't it? What is that? What is the EMF between the center and the metallic ring? Means this EMF we have to find out. Okay, this EMF we have to find out. So how to do that? So first of all, we need to know what is the area, how the area is changing, isn't it? How the area is changing, because the, you see, the area is perpendicular to this plane or not? Perpendicular to the plane of the ring, right? This is the ring. Ring is on the board. So plane of this is this one, isn't it? So perpendicular to the plane. So now I am taking this way. Okay, fine. If I am taking this way, then this will be in this direction, isn't it? Area will be in this direction, B is in the other direction, isn't it? So 180 degree. Don't bother about that sign, negative, because cos 180 is negative, isn't it? So don't bother about the sign, because we need only the magnitude. So now, so cos 180 means, so B is equal, phi B is equal to how much? Solution. Since B theta between B and, since theta between B and A is equal to 180 degree, am I correct? Is equal to 180 degree. This implies mod of phi B is nothing but BA, because BA cos 180, isn't it? BA cos 180. So I will write phi B is equal to how much? B times of A. Right, we have got this. Am I correct? Phi B. Now, okay, right till this. Okay. Now what is happening? Area is changing, isn't it? Area is changing. Am I correct? Phi B. So this area, you look here, if it rotates like this, when it, so what is the frequency? Frequency is nothing but 50, isn't it? So 50 means frequency is 50. So for in 1 second 50 cycle it is covering. In 1 second it is covering 50 cycle, isn't it? 50 hertz means in 1 second 50 cycles. So per second it is 50 cycles. Now 1 second. So 1 by t is equal to how much? 1 by t is equal to 50, isn't it? So t is equal to how much? 1 by 50 or not? 1 by 50 second, right? 1 by 50 second. This. So here f is equal to 50, so 1 by t is equal to 50, so t is equal to 50, 1 by 50 second. That means for one cycle it takes 1 by 50 second, isn't it? Area is how much? For one cycle area is how much? For one cycle area A is equal to how much? Pi r square. Am I correct? For one cycle area is pi r square. So this distance or area also we know. So what is that? We know E is equal to what? D phi B by dt, right? D phi B by dt. D phi is how much? Here B into A, and time is how much? That is the time period T. Directly I can write it, isn't it? So B is how much? How much Tesla? I've forgotten.
1 Tesla.
1 Tesla, right? So 1 area is how much? Pi r square is how much? Pi r square, better I'll write. Pi r square by time is nothing but 1 by 50, isn't it? T. So 1 by t is 50. So 1 by t is 50. Directly I will write. So this will give me E is equal to pi r square is 1 into 1 by t is nothing but 50, isn't it? 50 pi. So E is equal to how much? 3.14 into 50. Am I correct? So E is equal to 31.4 into 5, right? So E is equal to 5 4s are 22, 5 1s are 5, 2 7, 5 3s are 15. So 150 volt. E is equal to 157 volt. This will be your induced EMF, okay, between the center and the circumference. Got it?